Now that we're all refreshed and we've got our brain cells moved a little up a notch, it's time to move on to our next segment, which is going to be a very insightful panel discussion focused on conversational AI with our US team. We will have Krish back on screen to moderate this one for us. Please do feel free to use the Q&A tab at the bottom of your screens to submit your questions, and we'll have the panel answer them towards the end of the segment. Welcome, Krish. Welcome, panelists. Krish and the panelists, the screen is all yours.
Thank you, Ambika. I'm delighted to host this panel on building conversational assistants. I have with me the team that consists of Alex, Kyung, Nandini, Ozan, and Vinay, who have worked on conversation design, AI models, and coordination with the larger team in India. First, I'd like to set up the context for conversational commerce. The pandemic has brought in change in consumer behavior, with people embracing digital platforms. And we have seen this even in the remotest parts of India. And rightly so, as in the wake of the pandemic, e-commerce played a vital role in supporting the demand and supply framework by making both essentials and non-essentials available for stay-at-home consumers. I feel that e-commerce will continue to play a significant role in bridging the socio-economic divide by solving for tier 2, 3 cities and beyond, bringing more consumers into the e-commerce fold while breaking the language barrier and building an extensive last-mile delivery network. The technological capabilities like regional language interfaces and voice assistant have been the key enablers for creating a more sustainable e-commerce ecosystem, which is both empowering and inclusive for all Indians. The members of this panel have been working on a product called Decision Assistant, which we just launched at BBD 2021. I'd like to first start with having each member do a quick introduction. Alex?
Hi, I'm Alexander Sunell. I work on program managing the Conversational AI project, as well as some human labeling initiatives.
Thank you, Alex. Kyung?
I'm Kyung, Senior Data Scientist. I work on Q&A models related to user-generated content, intent models, and answer generation.
Ozan?
Hey everyone, I'm Ozan Ersoy. I'm the Senior Data Scientist. I lead one of the conversational bot projects, specifically the Decision Assistant bot. I also work on answer spam-based Q&A models.
Nandini?
Hi, I'm Nandini. I should say I was born in India, and I've been at Flipkart 2.5 years, where I look after the design teams for both content and conversational commerce design. We're responsible for how we interact with users in all 12 languages that we support.
Vinay?
Hi everyone, I'm Vinay Dandan. I'm a data scientist on the team. I work on retrieval models, entity recognition, and ML ops or machine learning operations.
Thanks everyone. So my first question is really for Nandini. How is conversational AI helping users in their shopping journey?
Well, through the chat, and we also have voice interfaces that we're building, our team is exploring how to enable our tech solutions to support users in a way that meets them where they are. And what I mean by that is that they know how to talk, and they know how to shop, they know how to chat, but we're working to make it possible for them to do that more comfortably online. So we want to make it easier to do what they came to do. One of the ways we do this is when we talk through our product and our design is we're always falling back to the familiar constructs of the physical shopping experience. So we consider things like whether the conversation we're building is in a particular context in the upfront part of the store, or leading them to the selection that they ask for, or helping them choose the selection, assisting in their purchase decisions like the Decision Assistant that Ozan mentioned, and making it easy to get help afterward. So to make that more accessible for people who've never shopped online, we also stick to everyday language, and we give them a chance to use their own words, just like when they're shopping with a shopkeeper, instead of using the terms that some of these users are unfamiliar with, like cart and checkout, which are familiar online only.
Thanks, Nandini. And I'm sure you've brought all your experiences from Google in helping design our conversations. Ozan, you were the first hire on the data science team. What are your thoughts?
Yeah, so as the first data science employee, let me talk about some of the initial challenges. When I started working on the project, I had to look at the data, talk to stakeholders, scope it up, and create a roadmap like the normal routine. But I quickly realized the sheer scale of the project. I'm not just talking about the number of customers that Flipkart has. When I say scale, it's rather an attribute of complexity. I was very quick to realize that we were tasked to work on something that had never been done before. So then we determined that some of the most tried methods wouldn't work, or perhaps couldn't work as fast as we would like them to work. Then the initial challenge was to increase our internal confidence in the latest state-of-the-art technologies and have the courage and to be bold, audacious, and to try them out. And we did that with proof of concept projects, and we still do actually. Today, Vinay and I and Kyung, we're all working on some proof of concept projects. The real challenge is obviously to execute all these ideas that we proved that it could work. And believe it or not, there is a way to boil the ocean if great teams work together, which is what we have.
Thank you, Ozan. And Ozan has a vast amount of experience in consulting, and he brought all this together to help us get started. And I love the POC that Ozan did that helped us understand what we're really going to build. Alex, can you talk a little bit about the challenges of managing such a program?
Yeah, certainly. So yeah, executing on those ideas that Ozan was talking about relies on inputs and expertise from multiple teams, from design, engineering, operations, data science, product. And additionally, we're drawing on data and intelligence from across Flipkart. This, however, of course, adds a lot of management complexity as we need to coordinate between multiple teams that often have different charters, different goals. And there's an added challenge working in the US when most of the team is in India that we're working across time zones. So, 12 and a half hours away, it's a little bit of challenge of when we're awake and asleep even. So we have to bring together these functionally distinct teams to a single program. And we bring together add-in processes such as weekly status updates where we're able to share the highlights of what we're working on, challenges we're seeing, and risks. Collaboratively reviewing metrics as a team, identifying those blockers and dependencies that allow our, that would potentially stop our project in its tracks. And some of the parts I like most are doing kind of collaborative analysis. So have designers looking at data science problems and engineers looking at product problems so that we're all working together as a single team to execute and bring those ideas to life.
Thanks, Alex. And Alex brings a lot of experience from Microsoft, where he was on the image sciences team and managed a lot of complexity out there. Kyung, in your view, what are the challenges in answering questions only from product descriptions and specifications?
Yes, Krish. Product descriptions and specifications on e-commerce product pages are based on information from manufacturers, but such information is often incomplete. In addition, the manufacturers tend to boast about their products and neglect the demerits of their products. But when you look at the user-generated contents, like user reviews and FAQ, you are totally in a different world. I would say a complementary world of information, where users take everything in the product specs and descriptions with a grain of salt and openly talk and discuss the demerits of the products. Lastly, based on the product descriptions and specs, it is very hard to answer subjective questions, such as, does this phone take good night shots? But user-generated contents, such as reviews and FAQs, are often useful to answer such questions.
Thank you, Kyung. Kyung comes from Porsche, where he built a lot of things in this area. Finally, Vinay, can you tell me what some of the challenges in your mind are?
Yeah, sure, Krish. So Ozan just talked about building POCs and showcasing the potential of a model, right? So that, of course, we do that. We train multiple ML models all the time. But once you train a model, you have to ask things like, how do we deploy them in production? How do we monitor them? How do we improve these models? And how do we keep updating them based on different time frames. So these things add a lot of engineering complexity to machine learning, and it is quite challenging.
Thank you, Vinay. And Vinay comes from IBM. He has seen a lot of these problems and helped solve some of these problems. So I'm going to start talking about. Sorry, Nandini. I missed you here. So Nandini, what are some of the challenges that you have encountered in this journey?
Sure. Well, the challenge is really at the base of human existence almost, because it has to do with user expectations. I found over the years that designing for the future really means going into the past. We're bringing technology closer to the natural ways we've learned to interact over hundreds of millennia. Language is it's really one of the triumphs of the human condition. So the biggest challenge is that because language and conversation are deeply part of who we are as humans, that becomes how people inherently compare their interactions with the machine. And machines are better than humans at some things, a few things, but talking and chatting is not one of them. So we're having to face that challenge of those high expectations to try to meet when establishing that interaction model as the interaction model itself. So that's the main challenge.
Thanks, Nandini. My 6-year-old niece, I think, does a better job than lots of machine learning models out there. She's done it very quickly in 6 years. Ozan, I'd love to understand some of the technologies using, especially wide deep learning models.
Sure. So yeah, we're working on conversational AI, right? So what does that really mean? So one of the researchers, Stephen Roller at Facebook, pays a homage to great Alan Turing and has a quote that I like a lot. Dialogue is sort of an AI complete problem, and you would have to solve all of AI to solve dialogue. And if you solve dialogue, then you've solved all of AI. So if you think about it, a conversation between two human beings has very many complex dimensions, as Nandini mentioned. And to simulate a small portion of that, we need complex algorithms. Sure, there are a lot of tasks like classification we can pull off reasonably well with simpler machine learning models like support vector machines and graded boosted trees. But text classification is one of the simplest NLP tasks that we work on. Plus, those bag of words approaches do not carry the contextual information. So how about machine translation, what you're talking about? How about reading comprehension? How about answer generation that Kyung mentioned? So those models are, the simpler models are not going to work. Thus comes the deep learning world, right? So obviously the breakthrough of transfer learning in NLP happened in 2019 with language models that are trained on the transformer architecture. Namely, the most famous one obviously is BERT and Albert, T5, GPT-3, Electra, Roberta, you name it. We use every one of them somewhere in our project, some as the actual inference model that we developed and trained on our Flipkart data, some for data augmentation and synthetic data generation elsewhere. There's also, a big major dimension selective model architectures to consider here, obviously, and that's the latency, whether you want to run it on GPU and CPU and your resources.
Thanks, Ozan. A lot of things to throw at trying to talk like my 6-year-old niece. So, Vinay, can you love to hear your thoughts on DL techniques?
Yeah, sure. So as Ozan mentioned, right, classical techniques can only go so far. That's where deep learning really helps in capturing a contextual meaning, and it really helps us understand what our users are asking for. So apart from transformer-based models, which we use heavily, and Ozan already mentioned many models we use, we still use traditional deep learning techniques like recurrent neural networks, convolutional neural networks, attention, embeddings, and so on in our suite of ML models.
Thanks, Vinay. Now, with these big models, obviously, you need to worry about latency. So can you talk a little bit about how we think about latency and what we've done to optimize for latency?
Yeah, sure. With these big transformer models, latency takes a hit on CPU when we use a CPU for inference. That's why we need a GPU for inference, but they're not cost efficient. So how do we make sure we reduce our latency while keeping our costs low? So that's where there are techniques like model pruning, distillation, quantization, which will help reduce the model size and improve the latency. But sometimes they also reduce model performance. So again, we have to think about how do we make sure we keep our latencies low while not reducing our model performance. So that's where we partnered with NVIDIA, and they really helped us in one of our models in bringing down our latencies by a high order of magnitude. And probably we can optimize even other models well.
Thank you, Vinay. Let me turn this over to Kyung now. Kyung, can you talk about how you are leveraging user-generated content?
Yes. Yeah, there are mainly two types of queries. One is objective and the other one is subjective. To provide the answers to the subjective queries, the user-generated content, such as the product reviews and FAQ, becomes very useful. The reason is that in the user-generated content, you can find a lot of users' opinions and additional facts on the products. However, answering based on reviews and FAQ is not that trivial because the data format of the reviews is very different from that of the FAQ. The contents of the two data sources are quite different. The user reviews are more opinionated than the FAQ. Thus, how to interact with the users in a chatbot and which reviews and which question answer pairs to show first in the chat windows are challenging. So for this, we built a couple of deep learning models to retrieve answers from the reviews and FAQ. We also developed a classifier to identify whether a query is subjective or not, and another classifier to capture the sentiment of the reviews to show the majority sentiment reviews.
Thank you, Kyung. So, you have all these outputs from these data science model, but we still have to put together a conversation flow. So Nandini would love to understand how you put together the output of data science models in conversation.
Sure. Well, we use it in two ways, and it's really a combination of some of what Vinay and Kyung were describing. First, we take what the data science model interprets. It interprets what the user says and gives us that semantic meaning that we can use in the conversation. And then from there, we categorize it, and according to various expected topics about what the user wants to talk about, those are conversation starters, and we use those user responses that they have in our questions. So the other is serving up those answers. So to arrive at answers, we may ask a series of questions and about what the user needs and get their intent all in one phrase as to what they respond to us with, or somewhere in between. So the answer that we give may actually be just a simple phrase that we already have based on our business rules, or it may be a piece of data that we get from the back end that's just something from the product page. Or it's a dynamic combination of all of the answers that the data models are delivering to us to serve up that's derived from those either user-generated content or the specifications, all of that deep knowledge that's coming from the page. It's very hard to scan, and we deliver that up in this linear manner in a chat interface. So all of that creates a dynamic combination of interactions that are powered by both the data and by pragmatic language constructs that we're going for in this interaction model we've created.
Thanks, Nandini. And one of the things that I should mention is we work with a larger engineering team in India that actually puts together all this thing and actually makes a lot of the magic happen using the data science models and the conversation designs that Nandini is talking about. Ozan, when you mentioned scale, when I asked you about challenges. Can you elaborate a little bit more?
Sure. So when people normally say scale, they tend to mean the traffic, the volume, right? So yeah, sure, we have that at Flipkart. as Mayur mentioned in his presentation, we have close to 300 million customers, millions of them interacting with us on a daily basis, right? So from the perspective of what we're really building, we have all use cases of the shopping experience that Nandini mentioned a while back. You know, from the product specific questions to payment questions to warranty, returns, exchange, so forth, right? So each one of those use cases requires its own solution, right? So then that's the first dimension that when we say scale, right? And then we basically sell everything online. We're in a marketplace, so we have to answer questions for thousands of product categories. That is another dimension. So we also have to be able to converse in multiple languages. Further, we have to be able to interact in voice. These are all hard project requirements. So now coming to the actual question of how we're handling scale, we have to be really smart in our approach to scale across all these dimensions. So, and I'm going to sound cliche, but like smart, small, get good at it, and then scale in all of these dimensions.
Thanks, Ozan. And I also want to mention that we always think, whenever we come up with solutions, can we scale it across multiple verticals and so on? So we try to come up with solutions that tend to scale. Vinay, how do you think ML Ops can help with scale?
Yeah, so ML Ops borrows principles from software engineering and DevOps to help build machine learning systems. And it'll help us automate the entire data science life cycle, right from model development to deployment and monitoring. It also advocates for other components like data versioning, model registry, experimentation frameworks, feature stores, among other things, which are really specific for building machine learning systems. So using these practices will help us simplify our processes and make our lives easier when we scale to across all these dimensions. But unlike software engineering, this is a very new field, so there are no well-established tools yet. So it's quite challenging to scale our MLOps efforts while we are also working on our solution for a product. But we've come along in our journey, and we have made a lot of progress for automating from development to deployment in production.
Thanks, Vinay. And the better MLOps we have, the faster we can experiment, and the faster we can meet our customers' needs. So there's one area that we haven't talked about, and that is about supervised learning and labeling, right? And Alex has a lot of experience on this. So I'd love for you to talk about how we ensure our labeled data is high quality.
Yeah, as you mentioned, getting high quality labeled data it's critical to getting well-performing models and ensuring that we're measuring ourselves correctly. A lot of you have heard the phrase kind of garbage in, garbage out. And while it's not always the most exciting part of data science when we think of it, it's a critical component. So both for the training and evaluation of our models, we use human labeling to collect this data. And we take a number of steps to try and ensure that we're getting the highest quality data that we can get. The first step in this is defining what our ground truth is, which translates to well-defined labeling guidelines that allow human labelers to get the input data and apply the correct label. To ensure that these are high quality, we're going to be continually measuring the labeler quality as well as the label quality that we're getting. There are different ways to do this. One such way that we use is measuring a disagreement rate. So if we have two human labelers look at the same data and label it, are they getting the same result or not? The more often that they're not getting the same label, the lower likelihood that our data quality is lower. And then so we try and figure out how we can kind of improve and lower this disagreement rate. Different ways we can do that are through simplifying the tasks that the labelers do to reduce kind of the cognitive load that they're spending to do this task, and then continually iterate on the guidelines that we have to define that ground truth. The overall goal of this is creating consistency in this labeling process across many different tasks, projects, and features, and manage the challenge for labelers themselves.
Thank you, Alex. There's a lot more than just building models. There's a whole set of things we need to worry about, from ML ops to data labeling and so on, to make this project come alive. So I'm going to, ask a question, put Ozan a little bit on the spot here. Right, Ozan was the first data science employee. So how did you take the leap to join as the first data science employee?
Sure. Yeah, so let me tell a little bit about my personal journey. It was actually a tough decision for me because I used to live in the East Coast in Washington, D.C. area, friends and family over there and where I resided. So I had to, leave all that and come to Newtown. And so how did I make this decision an easy one? So I had to go through, as we are all data scientists and technical people, I had to go through the algorithm in my mind. So I evaluated several things. First, Flipkart as a company, it's a great company to work for. And actually, we've been chosen by impartial, independent organizations as one of the best companies to work for in India and in the world, perhaps. And there's a lot of information about that online. Please do look that up if you're interested. And we have a very different culture that I appreciate a lot here. It's customers first and employee centric. Integrity, bias to action are some of our core values. And so all of that checked okay for Flipkart. We're growing very fast, lots of opportunities for career growth. That's also a good thing for me. And the work actually is exactly what I wanted to work on and where I'm really passionate about and grow and contribute as a practitioner, which is the NLU, NLG, NLP line or domain in our data science world. And our team specifically has a startup mentality and a feeling. It's small, very active, quick, fearless, but we have the support and the resources of a very large company, right? So, when you put it all together, you can't really beat all that. I feel like in retrospect, I'm going to look back on this experience one day and say, this was one of the best decisions I've ever made. So, I'm grateful I did it so far.
Thanks, Ozan, and it's been a great journey. I've really enjoyed going down this journey with you. Kyung, I'd love to have you talk about culture and how you navigated the culture in collaborating with the DS teams in India.
Yes, Krish. As you all know, and as we already talked about, the AI Center here is not an isolated unit, but we are highly collaborative with teams in India. We have been learning from each other and contributing to other business units as well. The synergy effect has been so great, I would say. But of course, there have been some challenges. So, for example, I've been working closely with data scientists in India, and the collaboration has been awesome. We could make the chatbot even better by tapping into user-generated content. But at the beginning of the collaboration, I wasn't sure of the best ways to interact with the DS folks in India. Because literally we are sitting in different countries at quite different time zones and different cultures. And a couple of data science models related to the user-generated content were already developed by the India team for different business use cases. So to integrate these models into the chatbot, we need to evaluate the models again for our own use cases and modify and even upgrade them to become more appropriate for the chatbot. So first, I focused on building trust between the teams by listening to other people's opinions and responding to without ego, always coming back to the perspective of making a product better for customers, not for me, nor for any other data scientist, but for our customers. So this perspective really helped. Different opinions come together and different metrics into the ones suitable for the chatbot users. I believe that we have the best talent here at Flipkart. So we focus on understanding the talents and identifying where and how to apply them. Based on my long academic and industry experiences, I believe we are building an outstanding team here at Flipkart.
Thank you, Kyung. And it's been really great collaborating with you in the last year or so. I just want to thank all of you for your time on this panel. But before that, I think we have a few questions. I think we have, let me just quickly look at the questions. Give me a second. So let me take this question. How should the dialogue agent use user feedback to personalize or improve a deployed model? Who wants to take that?
Yeah, I can take that.
Go ahead.
So yeah, we do use the user feedback in terms of, let's say, thumbs up, thumbs down from our chatbot, and how much they interact with us on a daily basis. You know, do they wait for the answer, or do they leave off the chatbot and bounce? So we consider all this when training our models, and we also have our ops team label the data, which Alex talked about. So combining all these, we build a new data sets and retrain all our models and make sure our models improve on the things which we failed at earlier. So we regularly update and improve our models to make sure we take in user feedback.
Thank you, Vinay. I'm going to go with the next question, which is, instead of using a supervised approach for labeling data, which may consume huge resources and time, can we consider unsupervised methodologies that can label large amounts of data with less resources? Ozan or Kyung, who wants to take that?
I'll try to take first portion of it. We are actually using a lot of data augmentation techniques or data synthetic generation techniques. Overall, when you combine all of that, we do have few shot techniques, and now we're researching zero shot techniques as well, taking pre-trained models and creating synthetic data, making the language models learn what we want to do. So it's a little bit both, right? So in terms of we're trying to solve complex problems. The idea that in my personal view, we human beings learn through supervision as well, right? You don't become a medical doctor by not going to school. So, like, if you want to have models that are really, really good in what they are trained to do, like answer questions very, very high accuracy for precision and recall, without any supervision whatsoever, it will be very hard to do. Yeah, with zero shot learning, you'll get to a point, but is it good enough? So to us, it's a marriage of all those techniques to get up and going, and trying all those new ideas out there, and also using supervised learning to make sure we're on the right track. And if you're failing, bring that into the loop so that we can improve our models.
Yeah, let me.
Yeah, go ahead.
Yes. Semi-supervised learning part. Let me answer that. So as Vinay said, we have a thumbs up and thumbs down features from the chatbot, and these features are not the rigorously correct one. It could be biased, but still it has useful information that we can use to train our model. So for example, intent classifier, we can use the model predictions based on also the matching with the thumbs up and thumbs down, and based on the uncertainty-based active learning, we can improve our models. Yeah, so that's the one application.
Thanks, Kyung. So I know Ozan touched about this, but I think there's still a question on this. Assuming you're using complex deep nets, can you talk about the challenges in scaling these models? So maybe Ozan or Kyung, one of you can talk about this.
Scaling in terms of operations and infrastructure. So we have a very talented team that helps us, engineering team that helps us with a lot of that side. We do try to use smaller networks when we can, the whole operation side of things, there's the industry is growing very fast, so you can run multiple models on the same GPU. You can scale the same model on multiple GPUs. And if the models can actually run at a good latency on the CPUs, we also do that. GPUs are not the only solution out there. And we reserve the GPUs only for the most complex tasks that we can't solve on the CPU. It would take several seconds, to do the inference. So we're looking into all of that. It's a learning experience, and we're growing in that aspect as well. So far, our latencies and the way that we have handled our big business billion-day traffic was phenomenal, and we didn't have any hiccups. So we can comfortably say we're on the right track.
Thanks, Ozan. I just want to also add that one of the things you're looking at is batching, which means that GPUs can execute a lot of things at the same time. So when you get a lot of requests, you can batch them together and send it to the GPU and execute them pretty quickly. So that's one area we are looking at as a way to scaling this as well. So next question is for Nandini. Right? The question is, it's a very interesting question. What cognitive science concepts do we use to build trust with conversational agents?
That's a really compelling question. One of the ways that we need to build trust for users that we haven't invested time yet in, but we're looking at is users don't really have trust in whether these systems work the way they expect them to, as I was alluding to earlier. And that's through, it's often overlooked as an area of trust, which is small talk with chatbots and or sometimes called chit chat, where someone who understands how conversation works, they understand how computers generally work or how their phone responds to them on certain things. They want to see how this thing works, and it seems to be driven by a computer. So they'll ask it things like, what time is it? Or what's your favorite color? Or what day is it? Because they know and they can predict that answer because it's familiar to them. So if it can do those things, then they're much more likely to trust it with their greater problem that they're bringing to it. And it's particularly effective in a service environment where they're bringing problems as opposed to shopping. So that's an area that we are looking to invest in, but there's a lot more to it. But establishing trust means just ultimately about whether this thing works the way they would expect it to.
Thanks, Nandini. It's a really hard thing to do, and we try very, very hard to make sure that we earn the customer's trust. Last question for the day is for Vinay, which is, how are AI researchers looking forward to deploying these large models in mobile platforms?
Yeah, a great question. So that is the area of edge computing, I believe. So there are separate chips on mobile phones these days, both iPhone and Android phones, which are capable of doing these neural computations on the go, on the phone. So again, with these big transformer models or big models, it's very hard to directly deploy them on these edge devices. So you really have to make sure you compress the model, reduce the size, make sure there's an acceptable trade-off in terms of model performance, and then you can deploy them on mobile devices. I think there's ML Lite, TensorFlow ML Lite. I think there are things available which can help with edge deployments.
Thanks, Vinay. We are out of time here, but I really want to thank the panel for all your great inputs, and look forward to scaling new heights in the coming year in applying AI in bridging the socio-economic divide in India. And this is really important for us because it's not technology for technology's sake, but to really help the consumer, especially in the remotest village in India, participate in the e-commerce revolution. Thank you, Ambika. Back to you.
Wow, that was truly insightful. I'm sure all of us are walking out today feeling much smarter than when we walked in, always learning every step of the way. Thank you so much, Krish, for helping us moderate and helping the group share their insights with us. A huge thank you again to our panelists for sharing your insightful opinions with us, and we're surely taking these back as learning. Thank you to our audience as well for your wonderful questions and making this so great and making it a two-way conversation, even though we're doing this virtually. Really, really appreciate that.